Good morning, students. In our last class, we have seen related to functions. I have given the definition and I have explained the terminology related to the functions. And we also discussed what is interfunction communication or parameter passing techniques. Yeah, in today's session, we'll be discussing, we are directly going into the object-oriented programming. We'll discuss classes, objects, and all other object-oriented programming concepts. Not only the concepts, we'll see practically how we can write the programs, and we will see the execution and we'll see the output. Yeah, before getting into that, yeah, we have to know what is classes and what is objects. Yeah. When I explained this object-oriented programming concepts, there only I have explained, I have given the definition of a class and object. I told you that class is a blueprint and object is an instance to that class. So I have given the real-time example also. Whenever we are constructing or whenever we are designing or whenever we are manufacturing a product in real world, if you consider that product as an object, yeah, definitely we are going to have a plan for the construction of that object, plan for the manufacturing of that object. That plan is nothing but your class. So we said class is basically a plan for object. So then what is an object? It's an instance, or we can say example. It's an instance of class. Okay. So these two are the basic building blocks. Your classes, your objects, they are the basic building blocks for object oriented programming. Whatever program we are going to write, the program, if you want it to follow the object oriented principles, then definitely you have to include classes and objects into that program. Without these two things, your program will not become an object oriented program. Okay. So a class, as we discussed, it is a user defined data type. We as a user, we are going to specify what things or what properties an object should have and what state an object should have in real time. Accordingly, we are going to write the class. So that is the reason why we are calling your class as a user defined data type, because we as a user, we are designing it. Okay. So basically I told you, in order to achieve data abstraction or data encapsulation, we are using classes. Class, basically what it will do, it will combine both data members and member functions together as a single unit. So there we are achieving encapsulation. Encapsulation in the sense, it is encapsulating both data members as well as member functions as a single unit. That is the reason why we are calling class as a encapsulation entity. Okay. And it is a blueprint for your object. Yeah, in order to write the class in your programming, we use the keyword class only, CLASS. As it is a keyword, all things, all letters must be in small, in lowercase. So we use keyword class when we are writing a class in your programming. A class, it is something like your structure in C programming. The difference is, inside a structure, we are not keeping the functions. It is very difficult to put the function inside a structure. But whereas inside a class, we can put the functions as well. We call them as member functions, data members and member functions. Okay. So we use the keyword class to write the class, and after writing the class, at the end, we must have to put the semicolon. So I will show you the basic syntax for writing the class. So the syntax for writing the class, it's very simple. We have to start the syntax with keyword class followed by the name of that class. Class name. Yeah, immediately you have to start the open curly bracket Then inside it we are going to specify the data members and member functions. Data members and member functions. And after specifying these two things inside your class, we have to close the class definition. We have to close the class definition, and at the end we have to put the semicolon. Okay, so before writing this data members and member functions, we have to specify the access specifier. Access specifier, and this access specifier must succeed with a colon symbol. It is not a semicolon, rather it is a colon. What is access specifier or access modifiers? We'll see very soon. We'll see when we discuss examples of classes and objects. There we will see what is access specifiers. Okay, so quickly we'll get into the programming part. So as you can see here, it is a simple example for your class definition. Yeah, I am taking the real-time entity box, any random box. Yeah, definitely it is going to have some dimensions. Okay, when we say a box, it will be like a cube, isn't it? So it is going to have height, width as well as breadth. So all those things I am keeping over here, height, length and breadth as the properties of my box. Then we can calculate the volume of that box, isn't it? We can, in real time, we can calculate the volume of that particular box. So in order to calculate the volume, I am using a function, a member function known as getVolume. So this is my class definition. In programming, we'll see in detail. So here, as you can see, I'm following the syntax over here. When I'm writing the class definition, I'm following the syntax. So I'm using the keyword class followed by the class name. My class name is box, and then I'm using the curly bracket, open curly bracket, and this public is nothing but your access specifier. We have three access specifiers in C++: public, private and protected. That we will see in detail. We will see. So after that, data members. So these length, breadth and height, these are your data members. These three are your data members because they are going to specify the property of your box. Then we have getVolume. That getVolume is nothing but your member function. And all these things we are keeping inside a class only. So it is encapsulating your data members and member functions as a single entity, as a single unit. Okay, so we'll get into programming, and over there we'll see in detail how we are going to use this class in your program.